surface active structure systems. These are defined as the systems of flexible but otherwise compression, tension, and shear resistant surfaces, in which the redirection of forces is affected by the surface resistance and particularly surface design. The system members are primarily subjected to the membrane stresses, that is, the stresses acting parallel to the surface system. Surface in membrane stress condition, right? Now, the typical structural features are structure as space enclosure and surface shape. So, broadly based on these criteria, surface active structure systems are divided into four different categories. First is the plate systems, then a variant of plate system is folded plate systems, then shell structures, and after this there is another type of surface active system. They are inflated systems, and inflated systems are also known as pneumatic systems, right? We will cover about pneumatic system in detail in another lecture. So in today's lecture is basically on plate systems and folded plate systems, right? Shell structures, pneumatic structures will be covered later on, right? So now we come to the plate systems. Plate system, the main components are the plate panel shear wall, cross plate or the transverse plate, longitudinal plate, plate girder, cantilever, plate edge, plate boundary, shell edge, diaphragm, cross stiffener, edge beam, shell membrane, hoop girder, base ring tension, compression ring, the column support, bearing support, foundation, right? So again, same components or same type of vocabulary is also present in the bulk active structure system. What is the difference between the two? So about the difference, we will move to the first. The major difference is the depth of the member and the thickness of the member, right? That is where the difference is. In the bulk active structure system, what happens is the depth to the width of the member, the ratio is it not exceeds 1:5. Here the ratio is more than 1:20, right? So now it is shown in this slide about the plate structures. In the plate structure, in this figure, what is given is the different type of plate structures. What are the different types of plate structures? They are: first is supported at two ends, or second, a continuous, member supported at ends and at with the intermediate members also. And third one is a cantilever system, right? Now the third column gives us the span in meters which it covers, right? In the first case, this the covered span is up to 50 meters, and in second case again it is up to 50 meters, and with in case of the cantilever, span varies from 3 meter to maximum of 25 meters if reinforced concrete is used, right? Now we move to the other part. So let me see. Yes, here is it. Structural plate and the wall girders. What is its definition? The structural plates are flat planar girders which contrary to slab are stressed by the loads parallel to the girder surface. In their bearing mechanisms, they can be compared with the beam, but the stress pattern of the plate with increasing structural height only from half of the span on deviates from that of the beam, right? Then wall girders, likewise referred to as structural plates due to their shape, with heights measuring less than half of their span, behaves like beam. They are not plates in structural sense. So, what is the main difference between the slab and a plate? It can be seen on the extreme left hand side. There is a figure of beam. We can clearly see the right the fact which I had pointed out earlier was that same thing is visible in this diagram of a beam is the height to width ratio, that is depth to width ratio of the beam is not more than 1:5. But in case of this plate members, it is 1:20 or more, right? Now, so the stress pattern of structural plate differs from that of the beam in the following essential aspects. The distribution of the normal stresses no longer develop along a straight line. The upper plate section loses in its bearing participation through compression. The neutral axis moves far downwards and descends still further towards the support. The resultant of tensile forces in relation to the compressive zone is to be found further down, right? The diagram of isostatic grid lines, also called trajectories, in addition to the compression vault of the beam, shows a direct streaming of loads towards the supports. So all these facts are visible in the diagrams on the right hand side. How the plates behave, right? So the isostatic grid lines, because in this the force is streaming, it is being transferred gradually towards the supports, right? There are two set of lines here. One is the tension trajectories and other is the compression trajectories. Compression trajectories tends uh, they are they are starting from the two supports, and the and while the tensile trajectories, they are again at they are starting from the top of the supports and they move downwards, right? So these are the two things which are available, which we can see here, right? And now these figures show the wall girder systems with shear plate stabilizations. So here two different types of uh, surface active members are plates are used. One which acts as the girders which support the slab, and other one are the shear walls, act as shear walls. And here on the first in the figure, what we see is the one-way plate system, in which the uh, girders are along the longer span and in a single direction. Now, these are this figure shows the biaxial plate system. There are two sets of girders which have alternatively been used, uh, one over the other, right, along with the shear walls in these diagrams, right. Now we come to the three-fold bearing action of singly folded plates. What is a folded plate? What is a fold? To understand a fold, we should compare this plate with a piece of paper, right? And in a piece of paper, when we fold it, and after the fold, when it is folded again, it is the folds are introduced in that plate. What happens? Triangular system of uh, which tend to repeat itself consecutively is set up. But again, don't confuse it with the truss system, because in truss system there is uniaxial, because truss system is a vector active system, right? There are either there is a there there is a member is either in compression or in tension, but in surface active structure systems, both the type of stresses are carried by a single member itself, and it is a continuous member. So there is the two slabs are inclined at an angle in a folded plate system, right? And this mechanism is visible in these photographs and diagrams, right? Now, what are the advantages of single fold structure over a ribbed structure, right? First is the reduction of slab span to about half, because each fold acts as a rigid support, right? And second one is the elimination of ribs, because each plane acts also as beam in longitudinal direction. And third thing advantage is the increase of the spanning capacity through the increase of construction height, right? So now we come to the influence of folding on stress distribution and span capacity. Here, take an example. Example of system with single fold. We can compare it with a sheet of paper in which there is a one fold, right? So what happens? And then what happens? The edge stresses at the fold have same tendency. Stress distribution thus remains unchanged, right? Then if we introduce a two folds, then what happens? Unstressed horizontal plate will be loaded by means of shear edge stresses, therefore will be reduced. And as we go on increasing the folds, what happens? The edge stresses at the side on the side fold have opposite tendency through shear. They largely compensate each other, right? So stresses are further distributed as we go on increasing the number of folds, and the form approaches a cylindrical shell, right? Now, how does a surface active structure system of folded plates resist the stresses? First is, what are the different type of stresses it behave? First is stiffening against the critical deformation of the fold profile, typical forms of stiffness, right? It is in this, it is clear from these diagrams that there is a dislocation of the lower edges, buckling on both plates, buckling on single plate, change in the fold angle, and transverse stiffening. These are the stresses which a folded plate system has to resist, right? So this is, and then how these are resisted? These are resisted by having stiffening against the critical deformations at the free edge, typical form of edge beams, and then, right, and these are how the deformation is resisted by having an edge beam for step folding and for shallow folding, right? And in different conditions, the different folds or mechanisms have been introduced as are shown in these diagrams. And now come to what are because folded systems has n number of possibilities. First is the surfaces with the counter running folds, and its examples are shown here, right? And then comes the surfaces with counter running folding, right? Right, all these examples are the counter. Then surfaces with the conical folding, and here are the examples, right? Then comes the surfaces with the counter running folding. In this, what happens? The elevated centered profile with the profile depth larger than the edge profile, right? Then comes linear structure systems composed of folded surfaces. These are their examples. These are linear systems. These are also linear systems, right? Then comes linear structure composed of folded surfaces, right? And then single folded surfaces over special plan geometry, right? These are their examples. Then structure system through interpretation of folded surface. There are n number of possibilities in these, right? Then the surface system through interpretation of folded surfaces. These are its examples. Now we can compare the surface active structure system also with the platonic solids. What is platonic solid? Or we can simply say it as polyhedra system, right? Okay, there is it can be understood here. What is the basic uh, solid form with least number of surfaces? That is tetrahedron. And after tetrahedron, it is the square base pyramid. Here is the example of square base pyramid here. The three-fold action of the pyramidal folded plates are shown here. What are the different actions it is folded to? The integral stiffening against the deformation of the folded profile, and then stiffening against the critical deformation of free edges, right? Now, so that is end of the folded plate systems. Now, in the second lecture we will cover about the shell systems. Okay, so today's lecture is over now, so that's it. I'm going to end the recording here. So what was today's lecture about? It is about surface active structure systems, right? And the book which was followed was the structure systems by Heino Angel, right? So